Summation of two pulses. We progressively decrease the interval between the pulses each time we stimulate. So we are going to measure the force of contraction of the first and second responses in millinewton and use the value to describe what happens to the frequency of stimulation when we decrease the interval between pulses. We are determining the effect of two successive stimulation on the nerve and muscle, and we use these intervals or frequencies to determine that. So in our analysis, we are going to examine the table and we will describe what happened to the frequency of stimulation when we decrease the interval between the pulses. We are going to be using this table for the analysis. We will record the contraction of the first response on this column and the second response on this column. This is our point of stimulation, and this is where we have our first contraction, and this is the second contraction, and this is the second stimulus. So you can see that there are two single contraction with refractory periods. So as we keep on reducing this interval between stimulation, we are going to see what will happen to the wave. So as we keep on reducing, so now we are reducing the interval gradually. This is a point of stimulation. This is the second point of stimulation. You can see as we keep on reducing, you can see that there is no refractive period. It's leaving the baseline. So it's coming up and summing up as one. That is wave summation. So we are going to be analyzing our data from the first page here. Is the first block. So we're going to utilize our marker tool. I will drag the marker tool up here. 354.67, 354.67. Let's move on to the next data. For this one, we have 432.36, 432.36, and continuously, that is how we are going to be analyzing our data. So this is the next value for 400 millivolt. Now we are going to move. We have 353.37. Now we're going to move to the next. The second value is 405 millinewton. That is for 400 millivolt. 366.54 millinewton. The second one, second data is 406.55 millinewton. That is for 200 millivolt. 362.41 millinewton for the first. Let's move for the second. We have 409.13 for the second value. Our comment here is 100 millisecond. Let's move for the next value. This one is for 80 millisecond on the table. 337.63 for the second wave. 389.25 millinewton. 352.86 millinewton for the first. The second is 430.81 continuously, and for this one 358.28 millinewton for the second value. This is where we have our wave summation at 40 milliseconds. So the value here is 413.26 millinewton. That's where we have our wave summation at 40 milliseconds. All right, we still have some here after summation. Here the value is reducing at 20 milliseconds. After summation, the value is reducing. So we have 350.02 millinewton for the first, and for the second we have 352.34 millinewton. Then we have 12 millinewton. So after summation, what happens? Here we are having the opposite now. 335.05 for the second, 302.27 millinewton. So, and that ends, and you tabulate your result following this video. Tabulate your results in the table and answer the questions that follows.